So, welcome to Chemistry with RK. Today, I have come up with a question from Thermodynamics chapters, which is related to entropy change and Gibbs free energy change and enthalpy change, which includes all the three concepts. So, this question is asked in recent Advanced 2022 paper 2. So, the question is acetic acid can form a dimer in gaseous phase. The dimer of acetic acid is held together by two hydrogen bonds. If at 27 degrees centigrade, the Kc, that is equilibrium constant for dimerization, is given e power 10, and they are asking the standard enthalpy change for dimerization, which is given actually y calorie per Kelvin, and then they are asking the y by 10 value actually. So for that, they have given the value of delta H, that is hydrogen bond enthalpy per one hydrogen actually. But since we have two hydrogen bonds, we need to multiply it with 2 to get the hydrogen bond enthalpy for two hydrogen bonds actually. So R value anyway we know that is in calories, we take 2. So this is actually the structure where we see two hydrogen bonds. So this is one hydrogen bond, and then here also we have one hydrogen bond. So this is how the acetic acid molecule held together through two hydrogen bonds. For this, the given data I have written here, that is Kc value is given 10 power e power 10, and then temperature, that is 27 degrees centigrade, which is nothing but 300 Kelvin. And they're asking us to calculate the delta S naught. Okay, to calculate this, first we need to know the delta G naught, like which can be easily calculated by minus RT ln Kc. So the temperature value is given, and the Kc, that is equilibrium constant value, is given. Anyway, we know the R value. So by substituting, this is R value, and then this is temperature value, and then this is the log Kc. So after that, we will be getting that delta G naught value as 6000 calorie per mole. So and then later that delta G naught value we can substitute in this Gibbs free energy equation. Delta G naught is equals to delta H naught minus T delta S. So I told you earlier they have given delta H naught, that is enthalpy change per one hydrogen bond, that is minus 7.5 kilocalorie per mole. And then because we have two hydrogen bonds, as I told you, that we need to multiply with 2 so that we get the delta H naught, which is enthalpy change per two hydrogen bonds, which will come out as 15,000 calorie per mole. So after that, if you substitute the values, that is delta G naught value, we have got minus 6000, and then delta H naught per two hydrogen bonds, we have got 15,000, and then temperature value we have here, and then delta S naught can be easily calculated. So finally we will be getting the delta S naught as minus 30 calorie per Kelvin. Since they have given in the question that is modulus of delta S naught, we need to consider where the minus 30 becomes plus 30, which is given as actually y. This is given as y actually. Okay, and then they are asking in the question, that is y by 10, which is 30 by 10, which is going to give us a 3 calorie per Kelvin. Yes, this is the question, and which is an easy one, but most of the students will struck in the bifurcating the given data and then applying the application part. Okay, so please wait for the such type of important and frequent questions from JEE Advanced and JEE Mains, or maybe NEET. So see you in the next video with another question. Thank you so much. Keep watching Chemistry with RK.